Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Hariyat Yaakob from School of Civil Engineering, UTM Skudai. Right, today I'll be briefing about the T1 test, which is the California Bearing Ratio Test, or we known as a CBR test. As an introduction, okay, so this CBR test is developed in California Division Highways around 1930s. All right, this test is to evaluate the mechanical strength of the subgrade and the base courses, such as sub-base and road based. So when we have a high CBR, so meaning you have a higher strength material. The higher CBR it goes, the higher the strength of the material. So this CBR compares the bearing capacity of a material with a well-graded crushed stone, which is in this, they are using a California limestone. Okay, it's standard California limestone. So this test is according to AASHTO T193, or you can use BS13, British Standard 1377 Part 4. Right. So basically, in CBR tests, it involve two stages. Okay, involve two stages. First is the compaction test. Okay, I'm sure everybody knows what compaction test. Where from the compaction test, we will get the optimum moisture content, or known as OMC, and also the maximum dry density, or known as MDD. Okay, so next, once we've known the OMC and the MDD from the compaction test, we move into the second stage, which is the CBR test itself, where we'll need to prepare sets of samples that been prepared using at OMC, at optimum moisture content. All right, so these samples will be conducted, will be subjected to CBR test, and we will analyze and get the CBR values at 95% of the MDD. Okay, the MDD that you get from the compaction here. Okay, so it involves two stages. Okay, stage 1 is the compaction test, and the stage 2 is actually the CBR test itself. Okay, so for this slide, for this test, basically we are not going to use a soaked CBR, okay, because actually we need to soak the CBR for 4 days. It was too long, okay. So therefore we just use a dry sample, okay, without soaking them. Okay, as you can see in the slide here, these are actually the basic tools that we need. Okay, we need to have a mold, okay, the mold with a diameter of 152 mm, the internal diameter, and we need to have the rammer, steel rammer. Okay, steel rammer, the weight of the steel rammer is about 4.5 kilograms, and this is a surcharge load. Okay, surcharge load with a load of 4.5 kilos as well. Okay, 4.5 kilogram. Right. So what we need to do is we need to prepare 5.5 kilos of soil, okay, and we add some water to it, required water, mix it thoroughly, and divide it into 5 different portions here, 5 different portions of soil. So every portion will be put into the mold and compact with the using the steel rammer, all right, with 62 blows. Okay, with 62 blows for every portion. Okay, so we repeat the same process for the rest of the 4 portions of the soil here. So we're gonna have an 5 layers here, 5 layers of soil. Okay, so once we've done that, okay, we move on straight to the CBR machine. So this is actually the CBR machine that you can find in the lab. All right, so this is where the sample is. We put a sample there. This is the plunger, okay, and this is the dial gauge for the penetration reading. Okay, penetration reading, and this is the dial gauge to read the load. Okay, so what you have to do, okay, once we're on the machine, so the plunger will penetrate at 1 millimeter per minute. Okay, so what you have to do, you have to read the penetration here. So for every 0.25 penetration, okay, until 7.5 penetration, okay, you need to read the load, okay, for every 0.25 interval. All right, until 7.5 millimeter penetration, you need to read what will be the load here. Okay. So once you finish, okay, we repeat the same process for the bottom reading. Okay, just now we have the top reading, and then we turn the sample and repeat the same process, turn the sample and repeat the same process for the bottom. So we have two readings, top and also bottom. Top and also bottom reading for that particular sample. Okay, so once you finish conducting the CBR test, so this is basically the sheet form that you're going to use. Okay, so this is actually the gauge reading, okay, that you got from the CBR test. Okay, so for every 0.25 mm, okay, you need to read the values here, the gauge reading. Okay, what will be the values for every 0.25 mm until 7.5 mm. Okay, for top and also the bottom of the sample. All right, so once you have that data from the CBR test, you need to convert this value into load, the force, okay, in kilonewton, okay, the unit is kilonewton, by multiplying with this calibration factor. So calibration factor that we're going to use here is 0.04082 kilonewton per division. Okay, so by multiplying these values with this, automatically you will get the reading in kilonewton. All right, once you have the reading in kilonewton, then you have to plot. Okay, you have to plot penetration against, okay, you have to plot, let me, okay, make it better. Okay, you need to plot the penetration against the the load, okay, the load against penetration. So we have the load against penetration. Okay, so there'll be two lines here. One is for the top and another one for bottom. Okay, so there'll be two sets of line, which is one is for the top and the other one is for bottom. All right, now we'll have to talk in terms of the graph. Okay, so the lines that you plot, you might have three different style. Okay, this style number one, okay, you have something like this, and then this style number two. Okay, it depends on the material. Okay, what sorts of materials that you conduct. Okay, this for style number two, and this for number three. So you can see for number three, there you can see the line slightly looks like S. Okay, so once you have this kind of, if you have this kind of line, okay, what you have to do, you need to do some correction by having a tangent line, by drawing a tangent line that touch the surface of the graph. Okay, so as you can see here, the black color here is the tangent line. All right. So once this tangent line will cross your x-axis, so by having this, you know, the zero, okay, the zero here will move towards where it becomes at this point. Oh, it's too crowded here. Okay, the value 0 for your x-axis will start from here, where the tangent line touch the x-axis. All right, so this type number 3, you need to do this correction. Okay, if you have number 1 and number 2, no problem, you don't have to do any correction. All right, once you have that, okay, once you have drawn the line, the next thing that you need to do is to get what will be the load at penetration 2.5 and 5 mm. As you can see here, okay, as you can see here, this for graph number 1. Okay, if you have this kind of type of graph, you need to know what will be the load at 2.5 and what will be the load at 5 mm. Okay, let's say if you see here, the 2.5, they have roughly about 6.5 6.1 kilonewton, and at 5 they have about 9 kilonewton. Okay, 9 kilonewton. So once you have this value, you move into the formula here. Okay, the CBR value at 2.5 is equal to H, which is 6.1 divided by 13.24. This 13.24 is the load value for the California limestone after being at penetration 2.5 mm. Okay, so this is standard that you're going to use. Okay, 6.1 divided by 13.24 times 100. For the CBR at 5 mm, you have the Y, which is 9. Okay, 9 divided by 19.96. Again, this is the load for the California limestone after being penetrates at 5 mm. Okay, so you're going to use 19.96 for 5 mm and 13.24 for 2.5 mm penetration. Okay, once you have these two values, pick the highest one. Is it at 2 or is it at 5 mm? Okay, pick one only. Alright, same goes, the same procedure for if you have this kind of graph. Okay, at 2.5. Okay, what will be the value at 2.5? What will be the value at 5? And go into the formula and get which one is the highest one, which either 2.5 or 5 mm. All right. So this one, if you have a correction, okay, like this, if you have this kind of S type of graph, you need to do correction. You need to draw a tangent line. So therefore, your 0 here will move forward to this point, and your 2.5 is actually at this 4 here, and your 5 is actually at here. It has been moved, shift forward. Okay, and get your value H at 2.5 and Y at 5 mm, and report the highest one. Okay, so basically you're gonna have two sets of data, which is for top and also for bottom. Okay, CBR top and CBR bottom. Okay, now just to show you, this actually the data that you have if you conduct using a SOAK CBR for 4 days. Okay, you can see from the first one, this table is actually what data is a compaction data. Okay, compaction data from the compaction test. Okay, you need to convert, you need to find from the compaction test. We need to know, okay, we need to convert this value, the bulk density, convert it into dry density. Okay, then you can plot dry density against moisture content and get the value of the OMC and also the MDD. Okay, right. And this one is actually the value of from the CBR test. Okay, from the CBR test. For the SOAK CBR, basically you need to prepare 3 samples. Okay, 3 samples at OMC, and for each samples you blow with a different number of blows. One sample at 15, 35, and 65. All right. And you repeat the same process as I mentioned just now earlier, where you try to pick the highest for the top for every sample and also bottom for every sample. Okay, once you have this data, okay, then you can plot what? You plot CBR against the dry density here. Okay, dry density. CBR against dry density. Okay, basically you have 2 sets. One is for bottom, one's for top, and another one is for bottom. All right. If you remember what I mentioned earlier, the second stage is we need to know the CBR value at 95% MDD. All right, MDD. So let's say your MDD is for example H, 95%, 0.95 from H. Okay, let's say you will get Y, for example, 0.9% from the value of H, you will get Y. So Y, you refer to the dry density here. What will be the value of Y? You draw a line and get the value. So basically this is actually, okay, so this is actually the value that you want. The 95% of CBR at the CBR at 95% MDD. I hope it is clear for you. Basically, this is all the repetitions that you've learned during your highway engineering 2832 subjects during your second year. Okay, I think that's all for T1 test, CBR California ratio test. Thank you very much. Bye.